All right, page 55, page 56. Okay? So this week, today is Monday. And it was the odds. Thank you. So Monday. So we'll go over the homework. And then we have some review. Tuesday, we will go over what we assigned tonight. And we will have a practice test in which I will have the video of all the problems worked out. So the practice test, this is in the book. But what else am I giving out on Tuesday? Yeah, I'm going to give you a take-home test. Okay? And the take-home test, we will work on Tuesday evening into Wednesday. Does that make sense? Thursday this week, we have the actual test. And the last 10 minutes, you can use take-home test.
Sir?
Ma'am?
I'm probably going to have to do the take-home test like next week. Because tomorrow I'm not going to be here. I'm going to get my wisdom.
Okay.
Oh, so that means you won't be in school for the next 2 days, right?
Right.
How many days?
Cool. Will you remind me? I can give you the take-home test today. So at least you have it.
Yeah.
Is that okay? Cool. And then once you get back and you're back with us mentally, because they'll give you some stuff to make sure the pain doesn't build up. Once you feel level-minded, sometime next week, we'll have you do the test with us.
Okay. Yeah. Just trying to make sure that you don't do what I do. That we get halfway through.
All right, so my friends, this is the I highlighted and circled with the pink dotted. That take-home test is going to be a pretty good tool, and my gut feeling is the majority of you will do fine on most of the tests, and then you get to the one or two or three that you're like, ooh, I might need a little bit more guidance, okay? And that's where that last 10 minutes. If you try and make that last 10 minutes going, sweet, I'm not going to do anything till the last 10 minutes and I get the take-home test. The take-home test is not the same problems. They're similar, but they're different numbers. So if you waited that you're going to run out of time.
Also, too, like a lot of you guys have been coming up to me and asking questions like, how can I get my grade up? If you're doing all the homeworks and like you have like A on all the homework, but yet your grade is not like an A, it's like a B or a C, look at those quiz tests because those might be bringing your grade down. So if that's the case, what I really, really, really would suggest, highly suggest, wink, wink, hint, hint, is making sure you do the take-home test Tuesday. But then what you do is you highlight or circle the questions that you're not like, oh, I'm super solid on this. Or you're still like, kind of iffy on. Do that so then when you come Wednesday, we can practice those again. Practice that Wednesday night. So then when you do take this test, it doesn't totally bomb your grade, if that makes sense. Okay? Mm-hmm. That's the easiest way to get your grade up.
All right. We good in the hood?
Good in the hood.
All right. So what questions do you have for me on 1, 3, 5, 7, or 9? And all could be an answer as well. 7. Okay. I will not. 7's a good one for us to start with, kind of start thinking about. But this is, I'm not going to give you one of these on the test. Okay, but it's okay that we take a look at it. Okay, so on problem number 7, we want to solve for x. So we all realize that we have x and x. Now, it'd be nice if we had like 6x and 7x, because then we could just add them together to get 13x. Agree? Yeah. But 6x plus px is 6x plus px. It's nothing else. Okay, so what I want to start doing on this problem is this. Would you be okay with this so far? So z minus 2 equals 6x plus px. Does that seem okay? Now, we've talked about the distributive property. We talked about the distributive property, but we've never talked about undoing the distributive property. So let's just think about this for a minute. I have an x here, I have an x here. Do you agree with that? So could I do, whoops, go away. Z, come on. I could care less about the royalty. Could this be the same thing? I'm just looking at the right side. So I just want us to kind of think about this for a minute. Do you feel these are the same thing? One just has the undistributed version.
Just a quick question. If we're about to distribute x with p, isn't that going to be xp?
Or px, it's the same thing.
Same thing.
Yeah, order doesn't really matter. I mean, it could be x6, but that's kind of gross. Saying x6 and then 6x is more acceptable. But it theoretically, mathematically, is not anything different. So my friends, this right here, okay, so you have 6x and you have px, and p is a variable. So I can't add, yet, you know, it looks like I could have 7x's up there, but because I have that px, that p could represent any number, but we don't know what it is. So we have to think about, if I reverse distributed, think about this. If I were to go from here and distribute here and here, does that take me back to that? Okay, and that's a, and again, I'm not going to have this on the test, but it's okay for us to kind of start thinking about it. Okay? All right. So what do you think I should do at this point to get x all alone? What do you think? Well, I want x by itself. If I had 2, I just bring it back over and I get z by itself. Divide by? I like the divide by, but if I divide by x, x comes over to the other side, so I get z minus 2 over x. Can I divide by what? Close. Go a little bit more than p. Divide by this. So this whole quantity goes away, and that winds up giving me an answer of this. And I'll tell you what, this is one of those that would, it just kind of messes with your head a little bit because, well, one, we haven't told you how to undo distributing. It's called factoring. We haven't gotten there yet. But it's a good forward thinking. You know, it does kind of tickle the brain a little bit because it does look very strange to undo it. But that's all I'm doing is I'm just undoing it. I'm reverse engineering the problem. Like, dude, I'm doing engineering. Yep. So with that known, let's see if we can take that idea and slowly go back through number 5 and see if we can make number 5 work the same type of way. All right, first off, do we agree that we cannot add 4x and 5xy together to get 9xy? Does that make sense? Okay, so take a look at what we did on the left side. What do you think I could take out of 4x plus 5xy to get the x by itself? I could take x out, yeah. Okay, so I have an x here, I have an x here. So I have x, and then I have 4 plus 5y. And we realize we can't add 4 plus 5y together because one has a letter and one doesn't. Agree? Okay, so if I want x by itself, what's my last step on this problem? Yeah, by that whole thing of parentheses, right? You got something in your ear. Hearing aid? Okay. So these cancel each other out. So I get x is equal to g over 4 plus 5y. And again, this will not be on the test. But I mean, that is a tougher thing. If I do sneak it on the test, I will make sure I make it a bonus question. So it wouldn't hurt you to try it, but you could get bonus points. But I don't think I have it on the test. I don't think so.
No, I think we.
Do we? Okay. All right. So 5 and 7 are done. What else on page 55? Does anyone need to see 1, 3, or 9?
I want to see the square root one. That one I couldn't figure out. I think that one's like a lot.
Oh.
That one.
All right. So the square root one's not on this page. Does anyone want to see 1, 3, or 5? Or 1, 3, or 9? We're good. Okay. You have a square root one?
Yeah, it's the last one.
15? All right. Number 15. Let's take a look. 15. We have v equals pi r squared h. That one, Stone?
Yeah, that one.
Yeah, it is the volume of a cylinder. So I want to get h by itself. Well, how are these being held together? What math operation is holding pi r squared h together? Multiplication. What undoes multiplication? Addition. Cool. Yeah, I'm going to divide each side by pi r squared. Oh, well, thank you very much.
Is that procedures?
They are.
Okay, perfect. Thank you.
Yep. Looking for you. Coupon. All right, so pi's cancel pi's, r squared cancels r squared. So I get h equals volume over pi r squared. And again, it's just a way of manipulating stuff around to get a letter by itself or a variable by itself.
Gosh, that was so much easier than I thought of how doing it.
Yeah, we can get, I mean, probably won't, I think the worst problems are like 5 and 7, about as hairy as we would get, but again, we're not going to test that. I don't think it's on there. I printed up the test already, so if anyone wants the test, I'll give it to you early. I'm kidding.
We still got number 13, right?
13, you want to double check? All right, 13. 13, A equals 1/2 H, and then little b plus big B. So those are two different variables. And I want to get H all by itself. So that wants to be by itself. First thing I'd probably do on this problem is I'd multiply both sides by 2, because that cancels. So then I get this. So H times big B, little b added together. What undoes big B, little b? How do I move them? How do I move the b plus b? Yeah, divide it. Good. So if I divide both sides by b plus b, those cancel. So I get height is equal to 2a over little b, or lowercase b, and capital B. That's an H. It's trying to be an H. It kind of look like an L. All right. Anything else we see? All right, my friends. Let's turn to page 57, please, of our books. If you don't have your book with you, grab out a sheet of paper and a pencil or pen or lipstick or crayon. If you don't have paper, I got some underneath the Promethean board. If you need a pen or pencil, there's some in the desk drawer.
Also, too, they do have books in the bookstore.
Yeehaw.
So please get the book as soon as you can. And if you can't get the book, please let us know, okay? But it's only $5.
All right, page 57. I'm looking at problem number 1. That's the first problem I'm looking at. Okay, so we don't like fractions. Agree? So we've taught us a method that we can do to get rid of fractions. Okay, theoretically, all we have to do on this problem is subtract 1/2 from both sides. So you get 3/4 minus 1/2. Then you have to worry about dealing with adding and subtracting fractions. So what can I multiply all three of my terms by that is going to get rid of all of my denominators, all of my bottom numbers? If I multiply by 2, it'd work here, but it wouldn't work here. 8 would work, and if you chose 8, it's going to work. It's just you have to reduce a fraction at the end. I like it. But does 4 go into 4? Yeah, and 2 goes into 4, right? So if I multiply everything by 4, or 4 over 1, then this is going to give me 4x plus, well, this is like 4 over 2. What's 4 over 2? 2, okay. And this is like 12 over 4, which is 3. This became a nicer problem. So declaring fractions really works anytime you have fractions and you're trying to solve for a letter. So yes, we wound up getting an answer here. So I want you to see this. If you did this top move, if you said, well, if I did this, you do it one of two ways. I like my butterfly method, 6 minus 4 over 8, bless you, which is 2 over 8, which is 1 over 4. It works either way. Okay? So it's your choice if you want to deal with adding and subtracting fractions or if you wanted to clear the denominator. Okay? Friends, will you try number 3 for me in your books? See how you do? Oh, you might be behind me. I was like, where'd you go? Give that a try. See if you can figure it out. If you're not sure, do it kind of light so you can erase. Where'd you sit at the game? Out in the stands?
Yeah, I was with Sarah and Kat Saturday, and then Kat Allen.
Gotcha.
Kiddos.
I had to babysit the middle schoolers.
Oh, I yelled at them. There's a couple of them that were like very misbehaving, even for like middle school age.
So we had 3 times the amount of security just for the middle school kids as we did to the rest of the game.
Why do you think it was so rough teaching 7th grade?
I know.
Why are they even allowed to come for it?
I don't know. Well, there was one kid, he was shocked because you're not allowed to have noise-making devices. So this kid, I see original, I'm down on the field, and I can see up there, he's got a cowbell. So I radio up. I said, the guy in the blue shirt, black shorts, and brown hair has a cowbell. It needs to be removed. So the security gives him, I don't have one. I said, let him know that he's ejected from the game or the cowbell gets given up. Oh, friend had it.
No, my favorite was me and Kat caught Miss Allen, she's one of the teachers here, caught a middle schooler jumping the fence, and we both got out there and like, dude, just go through the front gate.
You guys caught me. I must have missed that one.
Well, no, because it was this whole back corner.
Oh,
And
in
all
the bushes.
the little middle schoolers were all right there, each other.
Yeah, they rolled that way.
You shouldn't be allowed to.
All right, friends, how do I get n by itself? Divide by 5, very good. And negative 20 over 5 is what? Very good, done. Okay, try number 5 in your books as well. See how you do with number 5. You might have to combine some like terms before you start moving things back and forth, but see if you can figure out number 5 on your by yourself. Did you get to that point as well? What do you see at this point where we don't even have to go any further? Yeah. Do you all recognize that these are the exact same thing? I mean, one's written as 3p plus 23 and one's 23 plus 3p, but they're the same thing. So those are the exact same. So if I tried to start subtracting things, I could get 23 equals 23, or 3p equals 3p, or if you go all the way, you can get 0 equals 0. So the thing is, this creates a true statement. And a true statement means how many solutions? Infinite. Infinite solutions. Okay? Huh. So I'll just shift over to that board. Yeah, but it won't be too bad. Friends, first thoughts on this one. What can we do first? Yes, we have a decimal. Let's not worry about it. What can we do, though? Do what? But do I have t on the same side? And one of them's positive, one of them's negative? Agree? So I'm going to combine like terms. So those actually cancel each other out. So did I find one of the mathematical secrets of the world, that 3 is equal to 11.5? No, what do we know? No solution. So you could write n/s, or we do that 0 with a slash through it. Okay? Notice I haven't even really worked it out. I just kind of combine things together. So 5 and 7 are kind of, let's keep those in mind. True statement. And some of you might be still struggling on this one. So if I subtracted 3p from both sides, I would get 23 equals 23, which is true. And that's your infinite solution. Do you see the difference between infinite solution and no solution? They're side by side for the most part. Does that make sense?
So wait, what you mean is that if there's an input without the question, there's going to be one and no solution right after?
No, not necessarily. But you will see one. There will be one on the test, I'm sure. I'm pretty sure there's a no solution and there's an infinite solution, at least one of each.
Next to each other?
I don't know if they'll be right next to each other. But don't be that kid that says, oh, sweet, I know there's at least one no solution, so you write no solution for every problem. Going, dude, I got one right. That won't be a good score.
One right.
Well, I understand.
It's not like the ACT where you put your name, if you put your name right, you get points.
Really?
Yeah. Don't do that.
When are the PSATs? Don't we have to take them next month?
Sure. There is a day of testing that's coming up in October. It's on a Wednesday. All right. All right. Number 9. It's infinite. Sweet. So 2c plus 7 minus 3c equals 7c plus 5. So let's distribute it. We have an infinite, someone said. I think that might be right. 5 times 7 is 35 minus 3c. And then distribute here. 7c plus 7 times 5 is 35. Those are like terms. Bless you. So these are the same, right? Even if you go subtract 7c and subtract 7c, I wind up getting 35 equals 35. So that is definitely an infinite solution. That is a true statement. If it was 12 equals 35, it would be what? No solution. Okay. So friends, let's give me an honest look at page 57, 1 through 12. Now, I've already worked out some of the problems. Is there another problem or problems on page 57, just the first page, that I could help you out? Go ahead. 10 and 12. All right. All right. Let me go. I'm going to go to the single page view.
Well, it's actually easy if you look at it, because half of 3x is, half of 6x is 3x.
Yeah, we can work them. Let's see what we do. So number 10, we have 3 over 2, and then b plus 6 plus 1/2 b equals 15 plus 2b. What do you think, friends? Should we combine? Should we get rid of the fractions first? We could do a couple of things. I think I would combine the fractions together on this. Could I combine, because I have 3/2 b and 1/2 b? What's 3/2 plus 1/2? 4/2. Okay. So do you see what I did? I made a mental note. I could have went through and multiplied everything by 2. But if I combine those together, that's going to give me 4 over 2b, which is just 2b. Agree? And then I get plus 6 equals 15 plus 2b. Oh my gosh, what is this? It's no solution. I subtract 2b from both sides. Nope, we didn't find one of the secrets that 6 is really equal to 15. That's a no solution. But did you see how I did that one? Now, some of you might be like, hey, could I have gone through and multiplied everything by 2? And the answer is yes, totally. That gives me 3b plus 12, 1b, 30 plus 4b. So combine like terms, that's a b. 4b plus 12 equals 30 plus 4b. So notice it might be equal to different numbers because we reworked it out, but we still get 12 is equal to 30, and that's also a no solution. So it works out a little bit differently, though the result is the same. So it's your choice which way you want to do it. There's not a right or a wrong. And then he also said number 12 you wanted to take a look at? I think you're making 12 a little more complex. Can I go half of 6?
Yeah.
Can I go half of 4? That distributes real nicely. Does that make sense?
Yeah.
All right, let's flip to page 58. 58. We'll go over the word problems eventually, but from 13 to 18, are there any of those you would like to see?
You said no word problems?
I'll go over the word problems in a little bit. 13 to 18. Ooh, what's unique about 14? What do you notice about the brackets? They're not parentheses, are they? They're absolute value, aren't they? Yeah, let's take a look at that. We haven't done that in a while. So let's take a look at number 14. Okay. I do not want to distribute over absolute values. Though it might work sometimes, it's definitely something that'll catch up with you, okay? So what do you think I should do to start working this out?
Draw a line in the middle. Just solve it without solve it basically just without using the divisions and brackets.
Yep. So should I add 6 first? Could I? Let's see what happens. Add 6. Those canceled, right? What's next? Divide by? How much? 3, yeah. Yeah, number 14. What'd I get? How'd I get 58? Oh. I was like, dude, 21 over 3 is 7. Okay. So now I've gotten down to this point. Does the answer exist? Why? You're absolutely right, but why do we know that?
Because if the answer is equal after the equal, it's not negative.
Good. So now that we have the absolute value on one side all by itself, and I have it equal to a number that is a positive number or 0, okay, it means it's going to exist. If that 7 was a negative 7, we could stop right here and say no solution. Okay? So this is positive, so we can do it. Now, let's see. I am going to drop my absolute value sign, so I'm going to get this as one of them. But then I have to write the equation a second time. What comes along with the 7 on the other equation? What's that? Negative. Very good. Okay. So notice I have two answers now. If I add 12 to both sides on this one, so I get b is equal to 19 because 7 plus 12 is 19, I believe. If I add 12 here, negative, let's see, something costs $7. I have 12 in my pocket. 5. There's my answers. I could plug those answers back into my original and see if I get the same thing. Let's see, 19 minus 12 is 7. 3 times 7 is 21. 21 minus 6 is 15. Cool, the 19 works. Plug the 5 in. 5 minus 12 is negative 7. Absolute value of negative 7 is 7. 3 times 7 is 21. 21 minus 6 is 15. They both work. Other than the word problems, is there anything else on that page you want to take a look at? That 14 was a good one, though. We haven't talked about the absolute value in a while.
What about 16, which is equals to C,
Oh.
or 16?
You know what? God, is it? I'll do both 15 and 16. I don't think this is on the test. It might be, though. So, Stone, do you remember if these were on the test? Where we're trying to determine what values make things have no solution? I can't remember what this is. So let's do this. So, we want to make, if we want to make no solution, if it was infinite solutions, what would C have to be on 15 if it was infinite solutions? 6. So any other number. So any number other than 6 gives no solution. Okay? Does that make sense? Because you can subtract the 2x right now and get negative 6 equals negative c. And as long as the c value is not the 6, so you don't have negative 6 equal negative 6, that gives you no solution. So let's think about this. What value or what sign or what numbers would have to be c to make it no solution in this case with an absolute value? Negative. Any negative number. Any negative makes no solution. Okay? 0 works. 0 gives only one solution, and any positive number would give 2 solutions. But with that C value, those are a little trickier. But I can't remember if they're on there or not. I will give you the for sure knowledge tomorrow. Okay?
I'm pretty sure 16's on there, but it would have an equal sign to something.
Okay.
15.
I just don't remember.
I think 15, yes, but it's less complex.
Okay.
If that makes sense.
Cool. All right, are we good up through 18? Time for the word problems? All right, so I'll just read this aloud. I didn't type it up, I'm sorry. It says, at a book fair. Does it matter that we're at a book fair? Is that mathematically anything relevant? No, it's just trying to give us a little story. It says a tote bag costs $5 and books cost $3.50 each. Okay, so you buy some sort of bag for $5 and then your books are $3.50 each. Okay? You spend a total of $19 before taxes. How many books and tote bag did you buy? So this is how much you... What'd I do? Wasn't me?
You laughing at
I'm
me?
sorry.
You can laugh at me.
You laughing at Mason?
I laugh at me all the time.
Whatever you can do.
Oh.
Ay, ay, ay.
It happens. Okay. So let's see. I bet you. So we have enough information up there to solve this problem. But let's try and make an equation. So the bag, we had to buy a bag because we didn't want to carry around books without a bag. So we've dropped $5 on a bag. And our books are going to cost us $3.50 each. So I know I spent $5 on a bag. And then I did this. That looks like a pretty good equation that we could go with. Agree? Because we bought a certain amount of books. I don't know how many we bought. We'll solve that if we drop $19. So let's see. Subtract 5, subtract 5. $19 subtract 5 is 14. We have a calculator, right? At least you will. What is 14 divided by 3.5? 4? It's a good thing we bought that tote bag for $5 because we have these 4 big old books we got to carry around with us now.
I don't like reading.
You know, when I was your age, I didn't either. And at my age now, all summer I read nonstop. I read a lot of books. I read 11 books this summer.
11?
Uh-huh. They were all, pop-up, scratch and sniff picture books, but hey.
Still reading.
No,
I wish books were only $3.50. That would have been so nice. They're always like $16 now.
Oh, no.
I'm over here.
my summers.
Unless if you go to the library, then it's
So
free.
this is how stir-up summer is. I wake up in the morning. I have breakfast because that's what you should do. Get on my bike, go for a nice ride, get to my gym, stretch, do some weights, ride home, have lunch because that's important. Go out back with a book to my hammock and usually lay in my hammock for about 3.5, 4 hours. In that hammock, there's something broken with it because I do fall asleep a few times. But that's my summer days. During the summer, yeah. Mm-hmm.
We got nothing else to do. Us teachers get summer off.
Did you guys not go on vacation?
Oh, we go on vacation. No, other than vacations and stuff like that.
How do you not get hard? Where are your friends?
I have no friends. My hammock is underneath a big old tree, so it's all nice shaded area. No pine cone. No pine cones in the tree above me. All right, problem number 20. Problem number 20. Ooh. Ready? Eyes on number 20, please. On page 58. 4 times the number plus 6 times the number is equal to 8 times the number plus 34. 4 times the number, 4x, agree? Plus 6 times the number, good, is equal to 8 times the number plus 34. Yeesh. Well, let's see. I can't write. 10x equals 8x plus 34. Subtract 8x. 2x equals 34. I went kind of quickly on this. So x is equal to 17. So my friends, I would like you to finish page 57 and 58 for homework. We'll go over any remaining problems tomorrow. And then we're also going to do the practice test. What I will also do is I will record all of the solutions to the practice test. But this practice test in our book is not the take-home test. Does that make sense?
But this is still good to practice, especially for people who are not doing well in this class.
there a way I could get my take home test today so I can do it with my tutor?
Sure.